In this video, we're going to continue talking about sequences and series, but in this one we're going to introduce summation notation. And summation notation is used in sequence and series, but it's used in a whole wide of other areas as well. So if we're talking about summation, let's talk about this. Let's look at a series, a sequence I mean, and let's go 5, 7, 9, 11, 13, 15. And if you notice, this is a pretty easy series sequence. You start with 5, and then you add 2 from there. 5 plus 2, 7, 9, 11, 13, etc. So the next one would be 17, 19, etc. So from this sequence, let's say we wanted to add up the first 5 terms. And if you want to add up the first 5 terms, then it's pretty easy. You just go 5 plus 7 plus 9 plus 11 plus 13 plus 15. And that's 28, 39, 48, 55, 60. Actually, I don't have a calculator, so I'm not 100% sure that's right, but it's just 28, 39, 48, 55, 60. I'm pretty sure that's right. So this is the idea of a partial sum, and that's the actual term that we use. A partial sum is a sum. It's not an infinite sum. It doesn't go on forever, but it is a sum, adding up a certain number of terms. And all we want to do is we want to make a more compact notation of this. So if we want to do a more compact notation, then what we do is we use this symbol right here. That's a Greek letter, sigma it's called. And all it means is to add up a certain number of terms. And we're going to have a counter variable. You can use any variable you want to. I'm going to use I. So what this means is, let's add up, and let's start a series of terms, and let's start off with I equal 1 and go to I equal 5. And this will be some type of function. Here it's just A sub I. So the way we read that is we start off at 1, A1 plus A2 plus A3 plus A4 plus A5. And if we go back, if this was originally defined as A, then we end up with just 5 plus 7 plus 9 plus 11 plus 13 plus 15, which is 60. And that's all there is to summation notation. Let's go over it again, and let's go over it more carefully. So you have sigma, and here you have some kind of counter variable. K is equal to 1 to 7, say. And here you're going to have some type of function, f of k. So this is called the argument. This is where you start. That's where you end. The k is what's called a counter variable. Let's not use that often. And this is the sigma letter. It's just a Greek S, and that's going to suggest that you're going to add. So let's do another problem. Let's go sigma. Let's do a j this time. J is equal to 2 to 5. Let's go 2 to the j minus, j should match, j minus 3. Well, the key here is, first we know we're going to sum, right? Because that's the sigma, that's what that means. And we're going to start off with j is equal to 1, and then go j is equal to 2, all the way to j is equal to 5. So we just plug numbers in. 2 to the 1 minus 5, right? We take the j. Actually, we're not going to start with, we start with j is 2 here, so we don't start at j equals 1. My bad there. You usually start at 1, but not always. Here we're going to start at j is equal to 2. And we're going to go 2, 3, 4, 5. So 2 to the 2 minus 5, that's 2 squared is 4 minus 5 is minus 1. And then you go 2 to the third minus 5. 2 to the third is 8. 8 minus 5 is 3, so you're going to add 3. And then you go 2 to the fourth minus 5. 2 to the fourth is 2, 4, 8, 16. That's 16 minus 5 is 11. And then it's 2 to the fifth. 2 to the fifth is 2, 4, 8, 16, 32. So that's 32 minus 5. 32 minus 5 is going to be 27. So if you go j is equal to 2 to 5 of 2j minus 3, then all you're going to do is you're going to plug in a j there, and you're going to start at 2, and then you can go up by 1 until you get to this number. So it's 2, 3, 4, 5. Then you just add all those numbers up. That's 30, 41, 40. And that's how you do summation notation. There's two typical ones. The first one is when you have I is equal to 1 to 10, say, A sub I. This is when you're given this, when you're actually given a series. So that's just going to be A1 plus A2 plus A3 all the way to A10, and then you'll explicitly be given A. That's one common sum. The other common sum is when you're not given a particular sequence, as you are this one, but you're given some type of formula. Let's say 5n minus 3. N is equal to 4 to the 7th. And here what you do is you actually just plug numbers in, right? So you go 5, n is 4, so you plug a 4 in there, so that's 5 to 4 minus 3. That's 20 minus 3 is 17, so you get 17 plus, and then you plug a 5 in. 5 to the 5 minus 3, that's 25 minus 3, which is 22. So you're going to add 22. And that's 4, 5, and then you're going to plug a 6 in. So that's 30 minus 3 is 27. And then you're going to plug a 7 in. That's 35 minus 3 is 32. And then you just add those up. That's 2, 4, 14, 18, carrier 1, 3, 4, 8, 9. I think it's 98 though. I did that really quick, so I'm not sure. Make sure and email me if that problem's wrong. But see, see the differences? Here you're given a sequence. Here you have a formula. So in this one, for example, you might be given that AN is equal to 3, 4, 5, 6, dot, dot, dot. So then that's 3 plus 4 plus 5 plus 6, 3, 4 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12. Let's see if I got enough. That's A1 plus A2 plus A3 plus A4. A5, A6, A7, A8, A9, A10. And then you just add those numbers up. And that's how you do summation notation.